Hi, as part of the learning series under Microsoft Azure, today we are going to see what are containers, Dockers, and Azure Container Instances. It's going to be a high level overview with information regarding introduction, what is it, how it can be used, what are the advantages, and what are the drawbacks. This is what we are going to see it in today's session. This is as part of the learning and the lab series, and this information will be helpful for your exam preparation or interview preparations. First, what is containerization? We can simply say that it is a type of operating system level virtualization. Containers are a form of lightweight virtualization that allows developers to package and deploy application in a portable and isolated environment. Containers are built on top of host operating system, sharing the host kernel and libraries, which makes them more lightweight and efficient than traditional virtual machines. Containers are kind of images that are made up of application binaries, app data, application libraries, application configuration files, making it a self-contained and run on a host operating system. They are typically managed by container orchestration platform such as Docker or Kubernetes. Now let's go back to virtualization, and from there we can try to understand containerization. Visualization is the act of creating virtual version of a physical resource. This can be entire computer as well as the storage and the networking components. Here we have one large physical machine comprising of large RAM and physical memory. We have one host operating system, and over and above we have virtual machines, and they have their own guest OS. Every VM has their own guest OS, their application binaries, app data, configuration files, file systems, services, ports assigned, and so they are self contained and run on a host operating system. We are, we are going to share this large physical hardware and make to multiple number of virtualized machine using a special software called hypervisor. In a single large physical hardware, you are having multiple VM sharing physical hardware. The guest OS can be different than that of the host operating system. If you see on the right hand side, we have a containerized environment. The changes between virtualized environment and here are as follows. The hypervisor is replaced with the container runtime. We have host OS only in the shared containerized form. There is no concept of guest OS here, as you can see it in the virtualized environment. In short, container is a sandboxed environment for an application which shares the container runtime. The container runtime is a shared one by many containers. So this comprising of three containers sharing the same container runtime and the same host operating system. Now, how containers differ from virtual machines? That is, virtual machines versus containers. Containers and virtual machine both provide a way to isolate and run application in their own environment, but they do differ in different ways. The main difference between the VM and the VMs and the container is VMs have their own dedicated resources, such as uh, such as CPU, memory, storage, while containers share the host operating system resources. This means that multiple containers can run on a single host, whereas VM needs its own host. Additionally, VMs have higher overhead as they need to emulate hardware and run separate OS. Containers, on the other hand, are more lightweight and fast to start as they don't need emulate hardware and boot very quickly as compared to virtual machines. In summary, VM provide a high level of isolation and security, but at the cost of increased resource consumption and higher overhead. Containers provide significant lightweight and efficient way to isolate application, but with a lower level of isolation and security. And virtual machines are designed for any scenario, whereas containers are all designed for a specific scenario, which we will see it in the subsequent slides. And this makes the difference between virtual machine and containers. Next, why containers are better than virtual machines? If you see on the left hand side, we have virtual machine and on the right we have containers. Containers are generally considered more lightweight and efficient than virtual machine because they share the host operating kernel rather than requiring full gust OS operating system for each container. This means that the containers use less resources and start up faster than virtual machines. Additionally, containers are more portable and can be easily moved between different hosts or cloud environment, whereas VMs are tied to a specific hardware and the hypervisor. Building containers take less time than building VM, so containers are better option compared to VMs. If you see here, building VMs, you can start with a new build. You can decide about the operating system among the multiple OS. You need to have a separate libraries which forms a heavy image and it will take more time to build. If you take containers for a new build, you will be using the same OS as that of the host OS. You can have separate libraries. It is more lightweight in terms of the image and it will take very less time to build it. And this makes containers better than the virtual machines. Why containers better than virtual machines? Additional information. If you look in this diagram, there are a couple of things you need to note down. Applications shares binaries. If you see here, app D, E, and F have same set of binaries and libraries. All applications share the same operating system, same hardware, and the container engine. And also, you need to note down that application specific binaries and libraries of containers run on the host kernel, which makes processing and execution very fast. Even booting up a container takes only a fraction of seconds because all containers share host operating system and holds only the application related binaries and the libraries. And so containers are always better than virtual machines. Next, see what are containers and how to make it up and where you can use it. Let's take a virtual machine. As you know in this diagram shown here, we have three VMs built over a common hardware. There is a host OS and each VM has its own guest OS. If you look here, we have Windows, Linux, and Mac OS as guest OS. We have a virtualization software that ensures the VMs are all built with the respective OS. Now let's see how this VM translated into container. The first thing is the virtualization software becomes container engine. VM software will become any of the container engine such as Docker, Kubernetes, or any other software like runc, container Hyper-V. The OS and the VM becomes runtime environment. As shown here, the VM becomes a runtime environment in the container, and all the virtualization software is replaced with the container engine software. The VM and the guest OS will be replaced with the runtime environment. So we have three containers sharing the same operating system. Now let's see what are the containerization softwares available. There are many containerization software exists, but these are the six popular containerization softwares exist. This containerization software, also known as container orchestration software, is a type of software that is used to manage and automate deployment, scaling, and management of containers. Some examples of popular containerization software include: first one, Docker. It's an open source containerization software used widely for containerization and in the cloud computing. The second one is Kubernetes. It's again a open source container orchestration system for automating the deployment, scaling, and management of containerized application. It provides a platform independent way to manage and deploy containerized application, making it easier to run and scale application in variety of environment. We have seen Docker already. The Docker is a tool for packaging and running individual applications. While you can use this Kubernetes, that's a tool for managing and scaling the cluster of application. Next one, Mesos. It's similar to Kubernetes in that it is a cluster manager for containerized application. Mesos uses a shared pool of resources in which multiple frameworks such as Hadoop, Spark can share the resources and schedule tasks. And you can use it to manage both container as well as VMs. Next one, Docker Swarm. Docker Swarm allows you to create a swarm, which is a group of Docker engines working together as a cluster. That makes a difference between Docker and a Docker Swarm. Next is Azure Elastic Container Service, otherwise called as ECS, is a fully managed containerized orchestration service provided by Amazon Web Services. It's used to run, scale, and manage containerized application and microservices on AWS. Azure next come Azure Kubernetes Services, that's called as AKS. Again, a fully managed Kubernetes service provided by Microsoft Azure. It's used to deploy, scale, and manage containerized application using Kubernetes on Azure. Well, this containerization software provides various features such as automatic scaling, load balancing, service discovery, rolling updates, and more. They also have their own CLIs, APIs, and interfaces for managing containers and their applications. Next, let's see how to containerize an application and using what. Step 1, create your own application. Let it be a .NET application with a RESTful API interface. You can use any tool or any GUI environment to develop the application and then compile it and keep it ready. And when you are developing that application, you need to identify the dependencies associated with the application. It may be a simple web.config or app.config or any other application initialization data. Third one, you need to build the application and prepare container images. So when you build an application, you will get the binaries with the framework and any other dependencies like third-party controls. You will get the binaries with the framework, third-party tools, prepare a Docker file that is nothing but a text file containing the commands. Build it using a special software calling Docker, and it will create a Docker image. Put the Docker image locally or in the local repository with version information and test those images. Ensure that the images meet your requirements. And you can build a series of registry with multiple versions like app1 version 01, 02, 03 or 1.0. And this can be utilized for deploying it into any environment, be it on premises or at the cloud environment. So the registry is a kind of a bookshelf containing various apps and services. And this is how you can containerize an applications. And this will ensure that you can form a quick containerized registry so that you can deploy the images in the cloud very easily. Next come what is Docker, Docker file and Docker image as well as the Docker container. So Docker is an open source platform for building the images, shipping them to a designated place and running distributed applications. It uses containerization technology to package and isolate application code and the dependencies from the underlying system. So what is Docker file? Docker file is a script that contains instructions for building a Docker image. It's a kind of text file that contains commands needed to assemble an image that is used by Docker build command to create an image. The instructions in the Docker file include, but not limited to, specifying the base image, installing the software and the dependencies, configuring the environment, and defining how to run the software when a container is launched from the image. So, what is a Docker image? Once a Docker file is created, you can use the Docker build command to create an image, which then can be used to launch container. A Docker image is a pre-built environment for certain technology or service. A Docker image is not the runtime. It's rather a collection of files, library, configuration files that build up an environment. Next, what is a Docker container? It's a kind of runtime environment to run the Docker images. A Docker container is a lightweight, standalone, and executable package of the software that includes everything you needed to run a piece of software. Next, let's see what is, we have seen Docker file is a kind of a text file that contains the commands. And from there, we form the Docker images and then ship the Docker images to the Docker container or the runtime environment and run the images. This is the this is the high level difference between what is Docker, Docker file, Docker image, and a Docker container. Now let's see more about Docker file, image, and a Docker container. Here, if you see on the top, you have the first step creating application or service using your standard tool. Let's take it's a .NET application with REST API. Identify the application specific dependencies, be it web.config or app.config or any other application specific initialization routines are all identified as dependencies. Use Docker software and then convert this it into a container image. And then the image can be tested in a separate test development environment. If you are okay, form a registry that contain multiple versions of your applications. And this is what correlated here. For this, you are using a editor or Docker to create a Docker file. So they are just a kind of text files containing instructions. And then you can use the Docker to build the images by running the docker build command. Once you have the image, put it there in a registry or a repository, and you can use any of the version whatever you build based upon your requirement. And the build up image, you can run it anywhere, whether it is in your personal laptop or in a server in the on premises or at the cloud or even on the edge devices. Now let's see more about the Docker file. Here we picked up a .NET application as a sample, and we have seen Docker file is a kind of text file that contain commands or instruction for building an image. So these are the set of commands that is used to build an image. The first one, from instruction, which specifies the base image. The next one, copy instruction. Sorry, before that, the work directory or app, it will let you to specify the working directory along with the application name. Next one, copy ensures that it's an instruction. It ensures that the files and the directories in the host to the container file system at app level. It just copies the application files to the container. Next is the run instruction. It's a command to restore .NET dependencies and build the application in release mode. Next, we have run .NET build. This is for building an application. Next, this expose instruction tells the Docker that container listen to the specified network port at runtime. Here it is 80. Next come entry point. This an instruction sets the command that will run when the container starts. So this is how a Docker file is formed. It's a very simple in nature. There are multiple, much more complex Docker files can be built very easily with the help of set of instructions like this. Next, using these instructions, you can perform any action right from copy files from one location to another location and then setting up your build, and then you can also change the port number as the way that you want. You can clearly specify the URL as an entry point so that it may be the bump page for your application. Next, how to use your Docker. Let's assume you have a .NET application comprising of code and it has its own OS and other dependencies. From here, you can form a text file that is nothing but the Docker file and use Docker build to create the Docker image. And the image is now ready for run. You can have multiple number of images. For example, if you change the code from one version to another, you will have a different image. And this Docker image can be run on a cloud environment using the Docker engine. That is, you are moving the Docker image to the cloud environment and run it rather than running the exes produced out of this code and put it here. So this is not the right approach. When you use the Docker, make a Docker file, prepare image, put it there in the Docker engine and run it. Whereas this path shows from the code, create exes and put it there in the exe. This is not the right option to host your image into the Docker engine. Next come why containers are better than virtual machines. Once again, see, these containers are generally considered better than virtual machine for several reasons. The first one is lightweight. They share the host operating system, kernel, and libraries, which makes them more lightweight and different and efficient than virtual machines. This means that you run more containers on a single host than what you could do with VMs. Second one, fast startup time. Containers start up much faster than VMs because they don't need to emulate hardware or boot a separate operating system. This makes them well suited for applications that they need to start and stop frequently or scale quickly. Third one, portability. Containers provide consistent environment across different hosts, which makes it easy to move application between development, staging, and production environments. Next come resource utilization. Containers share the host resources, which means that they can be more efficiently utilized than VMs. This also helps to reduce cost as you can run more application on fewer hosts. Next come consistency. Containers provide consistent environment across different hosts, which helps to ensure that the application behaves the same way in development, staging, and production environment. Next come isolation. Containers provide a level of isolation where the application and its dependencies run in an isolated environment. But this isolation is less than that of what you can really achieve through VMs. The last one is specific to management. Containers are typically managed by container orchestration platforms such as Docker or Kubernetes that provide features for scaling, load balancing, and rolling update. Well, it's important to mention that the choice between containers and the VMs depends on specific use case and the requirements of the application. In some cases, VMs may be more appropriate, especially when it comes to security and isolation requirements. Next, let's see an important service from Microsoft, that is Azure Container Instances, otherwise called as ACI. It's a managed service that allows you to run containers directly on the Microsoft Azure public cloud without requiring the use of virtual machines. It is the fastest and simplest way to run container in Azure, so you can use Azure Container Instances directly. There is no need to provision any virtual machines or learning new tools in order to use Azure Container Instances. Run your Docker containers on demand in a managed serverless Azure environment. These Azure Container Instances again have fast startup times and they can be accessed using an IP address or a fully qualified domain name FQDN. You can customize the size, either you can use Linux or Windows containers. Three ways to run your application in Azure. Well, there are many ways to run or to host your application, and these are the three simple ways to host your application it into Azure. The first one is use of virtual machines, and you can build your virtual machine, put your images there based upon the OS choice, and you can run your application. And you can make multiple VMs and configure it under VM scales it based upon to meeting your scalability and then high availability requirement. Next come, you can use Azure App Service. Build an image and then use Azure App Service to host your application and run the application. The last one, Azure Container Instances. Build your application using Docker, keep the image ready, and put the image in the Docker container or runtime, and that will make the application ready for use. You can access such application using IP address or fully qualified domain name. And these are the three ways that using which you can run your application. Next, we are going to see some other additional point with respect to Azure Container Instances. We have seen Azure Container Instances is one of your finest service from Microsoft Azure to host your containers, and you don't require any special tools in order to host your container it into ACI. It supports for multiple operating systems including Linux and Windows. You can use Azure Command Line Interface CLI or Azure Portal in order to configure, host, and manage Azure Container Instances. It supports for Docker images and also the Docker Hub, where you can keep multiple versions of the Docker images. You can access the containers hosted in the ACI using an IP address or a fully qualified domain name. Another important point specific to Azure Container Instances, which include you can specify the number of CPU core and as well as the memory required for container instances. It supports for persistent storage by mounting Azure file shares to the container. You can define group that can be organized it into multiple containers that share the same host, storage, and networking resources. So these are some of the important points that you need to note down under Azure Container Instances. Next come, what are the benefits of Azure Container Instances? There are five important benefits that you can leverage under ACI. The first one is it is very simple and fast way to run your container in Azure. Just use CLI or Azure portal to configure ACI and you can deploy any container image therein and start using it. It's a platform as a service, and so you can leverage all the benefits whatever you can use it under platform as a service. Third important one, they are serverless containers. You don't require any physical hardware to maintain, manage with respect to the software, hardware upgrade, and other stuff. However, the fourth important point is it is designed for simple small web applications. It's used for running some background jobs. You can schedule scripts in order to perform or to meet your application requirement. It's more flexible. ACI supports for variety of Linux and Windows containers, and so it is easy to host your application based upon the choice of your operating system. Next one, Azure Container Instances have their own drawbacks. The ACI is relatively a new service. As such, it may still have some limitation compared to other container orchestration solutions such as Kubernetes. And let's see few of the drawbacks. The first one, limited scaling options. ACI currently only supports scaling up or down by manually adjusting the number of containers in the given deployment. Second one, limited networking options. ACI does not currently support advanced networking features such as load balancing and service discovery. Third one, limited support for custom domains. Custom domains are not currently supported with the ACI. Next one, limited support for persistent storage. ACI does not currently support for persistent storage for stateful workloads. Next one, limited support for running multiple containers in single instance. The last one, limited monitoring and logging capability when compared to other mature orchestration solutions. I hope this learning video is helpful to you. With that, I end up today's discussion on container or containerization with introduction about Docker, which includes Docker file, Docker image, and Docker runtime. Next, we have seen about ACI and their uses, where to use it, and what are the drawbacks associated with the ACI. And I hope this video helpful for you for your learning purpose as well as interview preparation and exam preparation. If you like this video, go ahead and subscribe and don't forget to click the bell button. You will get my updated learning videos. This is not the end of the session. We will continue with a newer topic tomorrow, same time. Till then, stay safe. Bye now.